Hello students, in this class we will study duality and linear programming. So what is the concept of duality? For every LPP there is a related unique another LPP involving the same data which also describes the original problem. That is, whatever LPP you have with the same data of that LPP you can have or you will have another LPP associated. The original problem is called as primal linear programming problem, and the second one, the associated one, and the other problem is called dual LPP. So now you have primal LPP and dual LPP. The variables of dual problem are called dual variables, or these are also known as shadow prices of various resources. The dual of dual problem is called primal. Both the problems have same optimal solution, same objective function value. Duality minimizes the computational efforts. It also helps to avoid the use of artificial variables in simplex method. So these are the two main benefits of duality. To find dual from primal problem. Now the question arises how to find out the dual of given problem, primal problem. Okay, step 1. The maximization problem in primal becomes the minimization problem in dual and vice versa. Second thing is maximization problem has all the constraints of less than equal to type, while all the constraints in the minimization problem will be of greater than equal to type. Third step is coefficients matrix of the constraints of dual is the transpose of the primal. That is, the first column coefficients becomes the first row coefficients, second column coefficients becomes the second row coefficients, and so on. A new set of variables appear in dual. Definitely the variables will be different because the problem is different. If one is of maximization type, the dual will be of minimization type. If the primal is of minimization type, then the dual will be of maximization type. So the scenarios are different, so the variables will be different. If primal problem has m constraints, then there will be m dual variables and vice versa. The variables in both the problems will be non-negative. Okay. Next is, if the primal problem has n variables, then the dual will have n constraints. The coefficient C1, C2, Cn of the objective function of the primal will become the right-hand side values of the dual constraints, and the constants b1, b2, bm in the right-hand side of primal will become the coefficients of the objective function of the dual. And the last one is, if the ith constraint in the primal is of greater than equal to type, then the ith dual variable will be of unrestricted inside. So one can use these 8 points to convert primal into dual. Now coming to some duality theorems which are very important in case of duality. The first one, the statement of first theorem is dual of dual is primal. Second is the value of the objective function z for any feasible solution of primal is less than equal to the value of the objective function zd for the any feasible solution of the dual. So this zd denotes the objective function of the dual. Okay. Now, if either the primal or the dual problem has an unbounded solution, then the solution of other problem will be infeasible. Next is fourth theorem is fundamental theorem of duality. If both the primal and dual problems have feasible solutions, then both have optimal solutions and maximize Z is equal to minimize ZD. So this is that in case of feasible solution are existing, then the optimal values of objective functions of both the object problems will be same. That is maximize Z is equal to minimize ZD. So ZD is the objective function of dual. Here I have written where Z is the objective function of the primal and Z is the objective function of the dual. Then the comes last one, complementary slackness theorem. It states that if a primal variable is positive, then the corresponding dual constraint is an equation at the optimum. And number second, if the primal constraint is a strict inequality, then the corresponding dual variable is 0 at the optimum. And the same case is for dual also. If a dual variable is positive, then the corresponding primal constraint is an equation at the optimum. At the optimum mean at the optimum solution, when the optimum solution exists. If the dual constraint is a strict inequality, then the corresponding primal variable is 0 at the optimum. So these are certain theorems which play important role in duality. Now coming to correspondence between primal and dual solutions. Now what is the correspondence? The benefit of duality is just that if all the constraints of greater than equal to type in any problem, then we can convert that problem to dual and all the constraints will be less than equal to type and we will simply add slack variables and get the solution. Okay, that's one thing. So we found we can find the solution of the dual problem, okay, which is convenient to solve. So from the earlier theorems, so we can conclude then that the maximum Z is equal to minimum Z dash or ZD. But how to find out the optimal value of the variables of the primal problems of the solution of the dual? So this comes under correspondence between primal and dual solutions. So there are certain steps here. The values for the non-basic variables of the problem are given by the Zj minus Cj row of the dual solution under the slack variables. If there are any other कोई slack variable है तब, and under the artificial variables, if there is no slack variable in the constraint, after deleting the constant m, or simply we can say what we will do, m minus Zj minus Cj value, okay, which will give us, which will be the desired value of the variables. Okay, so variables means primal variables, primal decision variables. Okay, so this is one point. Another is values for the slack variables of the primal are given by the Zj minus Cj row under the non-basic variables of the dual solution. The value of the objective function is same for primal and dual solutions. So this is the correspondence and we will understand it with the help of an example. For example, this is the problem. The problem is of minimization kind. So this objective function and these are the, these are the constraints. All constraints of greater than equal to type. So if we solve them simply using surplus and artificial variables and solving this problem using this simplex method, we get the final table like this. So here, okay, the artificial variables are also below. Okay, this is CB. These are the values of the coefficients of basic variables. So these are the basic variables, and B, then x1, x2, x3, s1, s2, s4, and here a1, a2, a3, a4. Okay, so now this is the table is continuing. यहाँ से यहाँ तक and dot 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 means the below also table is here. So even a2, a3, a4 are here. So we can see here 0, 0, 0 plus 0.3 plus 0.1 plus 0.3 m minus this, m minus this. So all the Zj minus Cj values are greater than equal to 0. Okay. Now, therefore, the solution is optimal. And what is that solution that is appearing here? X1 is equal to 16 by 3 and x2 is equal to 22 by 3. Okay, So now minimize z is equal to minus of maximum of z there. So this minus of this value is 0.74. So this is how we obtain the solution, but there are many simplex tables involved here, and a lot of effort is required to obtain the final solution. Okay, now what we can do, we can use duality. We will use the, we can find out the dual of the primal. So what this is primal. Okay, how many variables here? Two variables. How many constraints in the dual? Only two constraints, and all the constraints will be of less than equal to type. So using the methods of converting primal into dual, we can find out its dual. So let this y1, y2, y3, y4 be dual variables. Therefore the dual is given by maximize z dash. Z dash means the objective function of dual. Okay, and this is 0.4 y1, 0.6 y2, and so on, subject to the constraints. Now we have only two constraints, and both constraints are less than equal to type. Very simply, we can use slack variables and solve with the help of simplex method. We get the final table as given below. So here, CB basic variable, value of the basic variables y1, y2, y3, y4, s1, s2. All these are the variables. So we can see here that y4 is equal to 0.3 and y3 is equal to 0.1, and these are the corresponding CB values, and we can find in the Zj minus Cj row that all these values are positive. So all Zj minus Cj greater than equal to 0, therefore the solution is optimal. Okay, now how to read the solution? Okay, the solution of dual is y4 is equal to 0.3 and y3 is equal to 0.1, whereas y1 and y2 are 0 because these are not in the basis. So the maximum z dash is equal to 0.74. So the dual's solution is this. Okay, now the question arises, how to read the solution of primal from the solution of this dual? Okay, so again, if we compare the primal and dual solutions, we can see that maximum z dash is equal to minimum z. So that is 0.74 both the cases we can see. And secondly, the values of the primal variables under the slack variables in Zj minus Cj row, that is x1 is equal to 16y3 under s1, and under s2 the Zj minus Cj value 22y3. So these are the values of the slack variables. These are the values of the decision variables, decision primal variables that we can obtain from the optimal table of the dual. Okay, these are the values, and these are there also. So we can conclude that if we solve dual only, we can find the optimal solution of the primal also, and with less effort. So this is how I demonstrated you the utility of duality in getting the optimal solutions conveniently. Okay, thank you so much.